In the vast darkness of space, most planets reflect at least some light from their stars. Some shine brightly, some glow faintly, but one planet almost reflects nothing at all. It is darker than charcoal, darker than black paint, darker than coal. Its name is Trieste 2b, and it may be the darkest planet ever discovered. Star about 750 light-years away from Earth in the constellation Draco. At first glance, it seems ordinary. It's about the size of Jupiter. It's classified as a hot Jupiter, a gas giant orbiting extremely close to its star. But when astronomers studied its reflectivity, they found something disturbing. It reflects less than 1% of the light that hits it. For comparison, Earth reflects about 30%. The Moon reflects around 12%. Even asphalt reflects more light than this planet. Trieste 2b absorbs almost everything. Imagine a world that swallows starlight, a planet so dark it barely glimmers against the void. Why is it so black? Scientists believe its atmosphere lacks the bright, reflective clouds seen on Jupiter. Instead, it may contain light-absorbing chemicals like sodium and potassium vapor. Its temperature exceeds 1,000 degrees Celsius, hot enough to glow faintly red, but not bright enough to shine like a star. So even though it's burning with heat, it appears almost invisible, a shadow planet floating in darkness. Now here's where it becomes even more unsettling. If you were near Trieste 2b, you wouldn't see a clearly defined sphere like Earth or Jupiter. You would see something like a faint red ember in space, a dim ghostly outline. It wouldn't shine. It wouldn't sparkle. It would just absorb. Light hits it and disappears. Planets are supposed to reflect. That's how we see them. But this one defies that expectation. And it forces us to confront something strange about the universe. Darkness isn't empty. Darkness can be physical. It can be a world. It can be massive. It can exist silently in orbit around a star, barely detectable. Now imagine if such a planet existed closer to us. If it were drifting through our solar system, we might not see it easily. Not because it's small, but because it doesn't shine. That's what makes discoveries like this important. They remind us that the universe doesn't follow our assumptions. We imagine space filled with glowing stars and shining planets. But there are worlds out there that refuse to glow. Worlds that absorb nearly all light. Worlds that hide. Trieste 2b was discovered using the transit method. As it passed in front of its star, it caused a slight dip in brightness. That's how we detect many exoplanets, by watching for shadows. Fitting. A planet discovered by the shadow it casts. That is itself nearly a shadow. Since its discovery, astronomers have continued studying ultra-dark exoplanets. But Trieste 2b remains one of the most extreme, and it raises deeper questions. How many invisible worlds are out there? But Trieste 2b is not just dark. It challenges how we understand planetary atmospheres. Most gas giants we observe have thick cloud layers made of ammonia, methane, or water vapor. These clouds scatter light. They reflect it back into space. That's why Jupiter appears striped and bright. But Trieste 2b seems to lack those reflective clouds. Instead, its atmosphere may be filled with vaporized metals and exotic chemicals under extreme heat. At temperatures above 1,000 degrees Celsius, materials behave differently. Molecules break apart. Light is absorbed rather than scattered. It is possible that its atmosphere contains particles that trap light almost completely, converting it into heat instead of reflection. In a way, the planet acts like a cosmic absorber, a near-perfect sink for starlight. And that makes it scientifically valuable. Because when we study planets like Trieste 2b, we are not just learning about one distant world. We are testing the limits of atmospheric physics. We are asking, how dark can a planet physically become? Is there a theoretical limit to reflectivity? Could a planet reflect absolutely nothing? Even the darkest materials on Earth, like engineered ultra-black coatings, still reflect a tiny fraction of light. Absolute darkness is nearly impossible. Yet nature, 750 light-years away, has created something that comes astonishingly close. Now imagine the night sky from that planet's perspective. Because it orbits extremely close to its star, one side is likely permanently facing the light, locked in eternal day. The other side may be trapped in endless night. On the night side, the sky would be filled with stars. But the planet's own surface would not glow back. It would be as if you were standing on a world that refuses to shine. No bright clouds, no pale reflection, just a faint red heat signature against infinite blackness. And that leads to a deeper realization. We often associate darkness with emptiness, but Trieste 2b proves darkness can be massive. It can be the size of Jupiter. It can orbit a star. It can hold structure and atmosphere and complexity, while appearing almost invisible. Somewhere in our galaxy, there may be thousands of similar worlds, planets we have not detected yet. Not because they are small, not because they are rare, but because they do not reflect enough light for us to easily see them. The universe may be filled with shadow worlds, planets that absorb light, planets that drift silently, planets that exist on the edge of visibility. And as our telescopes improve, we may discover that brightness is not the norm. How many planets drift in darkness, absorbing light instead of reflecting it? How many could we be missing? Simply because they do not shine? The universe is not just bright explosions and radiant stars. If you're fascinated by the darker side of the universe, by the worlds that hide in shadow, subscribe to Cosmonova, because not everything in space wants to be seen.